Hello everyone, welcome to my channel. So today we will going to learn about splitting data, and in our last lecture we have seen residuals. So let's start our splitting data part. So in splitting data we have two things like training and testing, as I told you earlier. So training and testing, in testing we generally take the data 20 to 30%, and training we generally take the data 70 to 80%. I will show you with the example. So here is the example. Here we have 10 rows, for example, and in the 10 out of 10 rows, 2 rows for testing and 8 rows for training we will take. We can also take this as randomly. We have taken here this last 2 rows, but we can take this 2 rows for testing from anywhere. Like we can take this first one, and we can take this like 7th or 8th, 7th. So this is about training and testing set. Now we will move to another part, which is simple linear regression. So here you can see the table of simple linear regression. As I told you earlier, if we will use simple linear regression, so we have only one x and one y. So this R&D is our x and this profit is our y. After the simple linear regression, we will see the straight line formula. So that simple linear regression, it depends on this y is equals to mx plus c in that formula. So where m is slope, c is intercept, x is predictor, and y cap is the predicted value. So whenever we will put this x in place of here m means slope multiply this R&D plus intercept, then we will get the predicted value. So this is about the formula, and now we will move to the point named as slope. What is slope? Slope is nothing but whenever you have this point, like this is here we have like this y1 y and this x. So whenever you will do like y2 minus y1 divided by x2 minus x1, so then you will get a slope. So slope, maybe it can be 0 point something, it can be 0.8, 0.9, can be like very least. Okay, so that means this is the slope. Okay, here you can see, here we will put some point and here we have some point, and we will calculate the slope. So now we have another thing which we can say, that is intercept. Okay, so in intercept you can see here the distance between from this starting or this line where this line is starting and between this 0. Okay, means the distance between this to this will called as intercept. Okay, so that is called intercept. So now we will move to the coding part. There I will show to you this all these things in a more detailed manner. So here we will see the simple linear regression code. Now first of all we have some steps. So step 1 is read data and find the best correlated columns. So first of all I will write import pandas as pd. So I am calling this df. So here you can see this my data set. After this calling this data frame, I will move to the part where we will see the correlated columns, because here we will use the simple linear regression. So we have to find which column is the best predictor. So now I will write df dot correlation. We know correlation. So then here it is showing you the best correlation is between profit and R&D. So how I am saying that, this one, like you can see 0.97, okay, and this R&D and this profit you can see. But if you will see this market and profit, it is not good, it is 0.7. but first of all, if we will take this as a decreasing order, so first we will take this 0.9, then we will take this 0.7, then we will take this 0.2. so that's why first of all we will take this R&D. So now this is our first step. Now we will move to the next step. So here, because we know we will take R&D, so we have to define X predictor and Y predicted value. This is working. X dot head, you can see top 5 rows for X, and I will also show you the head of Y, top 5 rows of Y. So this was our second step. Now we will move to the third step, which is splitting the data. So here you can see splitting the data into training and testing. So for saving the time, I already have written this code. So from sklearn dot model selection import train test split x train x test y train y test, and then this one train test split. Then we will pass our x and y, which we have already defined, and then test size is equals to 0.2. it means 20% test size and 80% training size, and random state is 42. Now I will run this first. So here you can see this x train is, this one is our x train. So it is taking randomly, right? The 12 4 37 8 3 etc. So this will take your data randomly, it will not take your data just continuously, okay? So that's why this technique is good to split our data. So here you can see the X test as well. So in X test you can see this is our testing data, okay? So this testing data we will pass, and then we will get the prediction. So this is the profit head, like first 5 rows for profit for training data, and then first 5 rows for profit for testing data. Now we will create the model. This is our step 4. So using this algorithm, okay? So how we use this algorithm, we generally say like sklearn dot linear model import linear regression. So this is how we generally import our this linear regression algorithm, and then LR, and so this is the variable which we will use. LREG is equals to linear regression. Then so that we can call after this. Then we will define a model is equals to LREG dot fit X train and Y train. So here we will fit our data, whatever the data we have taken here in 80 and 20%, right? So 80% data we will fit inside this regression model, and then we will see the prediction. So here you can see I will show you the model.predict at X train. So these are our X train first 5 data, okay? So this is the first 5 prediction, okay? Now if I will take like 93,863.75, if I will pass this value inside this, so then what it will give you, you just see. So it will give you the same value, okay, because this was the first row of X train, you can see here, okay, yeah, this one. So this one is our X train data, so that we are taking here, okay? That one is our first row. So this one is giving you this same value, okay? So that's how you can also pass directly that value, and then you can get the prediction. Now we will move to the another part. This is regression line. So step 6 is the regression line that we have to create here. Now you will see this is how it will create this regression line. Okay,